Welcome to the Green Urbanist podcast, where we explore sustainable placemaking, climate action in cities, and urban rewilding. I'm your host, Ross O'Kelly, an urban designer, educator, and sustainable placemaking consultant. Hello, today we're talking about net zero carbon buildings with my guest, Salem Qunsol.
My name is Salem. I'm a principal sustainability consultant at Verte, who specializes in whole life carbon. So I lead the whole life carbon team there. With Verte, we work with developers and our clients to help them create low carbon and resilient buildings.
As you'll have guessed, the topic of the conversation is the UK's new net zero carbon building standard, which is in a pilot version at the moment. It was released pretty recently, and it's now going through some test projects and will be improved and iterated on going forward. Salem was one of the many people involved in actually formulating the standard, and so he is joining me today to talk about why the standard is needed. Why do they make it? How do you actually define net zero carbon for a building? Some of the best practice approaches that the standard is encouraging people to follow when they're designing low carbon or net zero carbon buildings. And a range of topics within that related to circular economy, what kind of materials you use, is concrete still sustainable and there's still a place for concrete in net zero carbon buildings? What about natural materials and timber? How does the standard deal with that? So lots and lots of interesting topics and takeaways from this episode. Huge thanks to Salem for joining me. It was great to catch up with him. He was my guest on episode 12 of this podcast about 100 episodes ago. So really cool to catch up with him again. And if you want to learn more about the actual standard, you can download it and view it yourself. It's on the website, which has a really long URL, so I won't read it out here, but the link is in the episode description, so just go and click on that. You can also find contact details for Salem if you want to get in touch with him and talk net zero carbon buildings. So thanks very much for joining. Hope you enjoy this episode. I guess the main topic we want to chat about today is the net zero carbon building standard. Can you tell us what that is? How were you involved? Just give us a bit of backstory on that.
Yeah, absolutely. So this the new UK net zero carbon building standard. It's been a monumental effort that was done by consultants in the private sector within the UK, and I think it came from the need to define what net zero carbon means, partly to normalize that across buildings. It is building based, obviously, so it's not for organizations to call themselves net zero carbon. It's not for it's mainly for buildings. We've had in the UK prior to this a pathway to net zero carbon that was produced by the UK GBC, who are very much involved. So that's the UK Green Building Council, and they were very involved in this kind of the new iteration of the standard. But the idea behind it was to incentivize developers and kind of building owners to go towards improved buildings from a sustainability perspective. There's a big kind of backstory to all of this, I suppose. But for the longest time in the UK and around the world, we've been focusing on how much carbon is emitted during the operation of a building. So that's whether through electricity use, whether through gas use. I think everyone remembers all the time, whether it's at school, whether it's growing up, whether it's now, turn off the lights when you leave the room, don't leave the heating on while you're outside of the house, use electricity in an efficient manner, buy LEDs, and that's all very, very important. But throughout this whole time, I think the topic of embodied carbon has been lost. And embodied carbon is essentially the carbon it requires to build buildings and to refurbish them, to maintain them, to take care of them, and then towards their end of life. And I think that's a topic that's been kind of growing over the past decade or a couple of decades, but it's only really taken off over the past 5 years on how important it is. A lot of research shows that it can add up to the same amount of carbon that you emit during the operation of the building as well, over a period of 60 years. And through that, combining both this operational and embodied carbon, we've been trying to find ways to reduce both of them at the same time. I remember a few years ago when the UK GBC's pathway to net zero carbon kind of came out. That methodology was measure your carbon emissions, measure or estimate how much carbon you're going to emit due to building the building, and make an estimate on how much carbon will be emitted during the operation of the building, and then measure these, make an offset payment, and that's when you can start calling your building net zero carbon. So obviously a few little other things you need to do, but that's the essence of it. I remember seeing one developer kind of hit this net zero carbon on one of their buildings, and everyone asking about it afterwards. Everyone wanted to be part of this, which was great. It was very much driven by clients, driven by consultants pushing for it as well, and it was a great thing to see. And since then, we've been trying to work to make it, I guess, more all-encompassing. So it would, now we have targets with the new net zero carbon standard. So rather than just measure and make an offset payment, you have to hit certain targets. These targets are based on the UK's carbon budget to be able to achieve the Paris climate targets as well of 1.5 degrees global warming. But yeah, it's going to be more challenging, I think, and that's the point of it, is to push push the whole UK, push all stakeholders towards it being more challenging. Clients will have to they will have to think a lot more about refurbishment versus new builds and demolition. They will have to think more about reuse. Even us as sustainability consultants, we have to be more creative with what materials we can use, where can we find more efficiencies. Structural engineers will need to be more creative with how they can reduce the amount of structures in there. So it's a very interesting time, and the net zero carbon standard came out as a pilot version. I think it was September last year officially. Now, just a few days ago, we finished submitting a lot of projects for it to be to kind of be tested under this pilot, with the final version, or the kind of the first official version, expected to come out towards the end of the year.
Great. It's interesting that you say that it's sort of making being a bit more rigorous and challenging around what you can call net zero carbon, because I guess from the outside it might seem like net zero carbon is like a very clear mathematical thing where you say, just add up, do your calculations for your emissions, and if it's zero, it's zero. But as you're saying, there's a lot of ways to get there, and you're sort of, the standard is trying to push people towards the ways that this body of industry experts thinks is the best way to approach it. Can you talk a little bit about like why that is, and what are some of those things you're pushing on?
Yeah, it's difficult with defining what net zero carbon is as well, because technically speaking, if you do decide to build a building, it is quite difficult to achieve it to be purely net zero carbon, just purely from just building it without thinking about anything else. You will need materials at one point or another, even if you build everything with timber, for example, or with materials that have been produced in a factory that is fully renewable energy. You will still need to transport it. You might think about electric vehicles, which is great. There will still be some form of element where carbon will be emitted, whether it's screws, whether it's it's some kind of glue to bring things together, finishes. Eventually whoever occupies the building will want to install some maybe potentially designer tables or something like that. There will always be, I think, carbon, and we're obviously working towards that. But what we've been trying to think of as well is, rather than with embodied carbon specifically, rather than thinking about just purely reducing carbon, we also want to reduce the amount of materials that's being used. And this kind of ties in a bit with circular economy, I think. Ultimately, the less material, the more efficient you are with your building, the less carbon you will have. And I think that's quite a nice pathway towards that. Previously, with how we were doing the net zero carbon, or how we were defining it with the UK GBC, you would measure your carbon and you would make an offset payment equal to that, how much that carbon is, essentially. So there's a a cost per carbon, which is variable, interestingly. So depending on how you decide to offset your carbon, there's different pricing, there's different ways of doing it. You can invest in building solar panel farms in different countries. You can invest in forest, kind of regeneration of forests, growing forests. In the UK, it's mainly forestry, so it's kind of grow a tree, and that tree is going to absorb carbon from the atmosphere, which will eventually offset the carbon that you've emitted as a result of your building. But we've had very interesting conversations around those as well, because I think the tree growing has been one of the more interesting ones, and eventually you run out of space where you can grow trees as well. Especially if you want to do it inside the UK. Ecologically speaking, there's been a few questions also around just growing trees in certain places when actually the balance of the ecology requires different things. It might not require trees specifically. As I'm sure you've seen, there's been a few newspaper articles here and there around some of these carbon offset projects not necessarily going through or causing different types of harm. But there are standardized ones that we know are working at the moment. These are the ones that are recommended by, well, not recommended, these are the ones that are required by the UKGBC to follow if you do want to become net zero carbon standard. But with the new standard, offset has become optional. The main thing is to hit the targets. The main thing is to reduce your carbon to hit certain targets. And these targets are changing year on year. So if you start building your building in 2025, then there's a certain target you have to hit for embodied carbon, for example. If you start building your building in 2030, then that target is much lower, and it moves down fairly quickly. With embodied, the targets are set per carbon, which is very interesting. So you calculate how much carbon is emitted, you check whether you meet that target. It's a per GIA target, and then that decides how you're doing. With operational carbon, so with your electricity use, and I'm going to disregard gas use because we're moving away from this in the UK at the moment. With your electricity use within your buildings, it's not measured per carbon, but it's measured per electricity use. So you the targets you have to hit are for energy usage rather than carbon emission. And the reason for this is that the UK is moving towards decarbonizing its grid quite well. If we're optimistic, we can say quite quickly. There's a lot of offshore wind farms, there's solar panels as well. So each time you turn on your lights and you use a certain kilowatt hour of electricity, that carbon cost year on year is reducing as more of the electricity grid is becoming renewable. So part of the idea with the net zero carbon standard is not to still think about reducing your electricity use rather than just depending on that decarbonization of the electricity grid to just counteract that, which is another interesting thing. So I guess that's a bit of a brief thing around it. It's kind of touching on quite a few different topics.
Yeah, I think it's like the reality is that a building is such a small system interconnected with everything else around it, and in terms of being plugged into that national grid of energy, and us, in a way not having that much power over how quickly oil and gas is being phased out in favor of renewables and that kind of thing. Yeah, I can understand how that, like, the standard has to bear that in mind. Is there I presume there is encouragement and standards within the standard, or targets within the standard, for renewable energy generation on site, so like rooftop solar panels, that kind of thing? There
is, yes. I'll have to admit, with operational, it's not my complete, so it's not what the part I was working on or my specialty too much, but yes, there is, you can receive benefits out of having operational carbon on site, whether it's solar panels on the top or
Yeah, and this is one of the interesting trade-offs from an urban design point of view, in terms of if you have higher density buildings, we'll say in city centres, and you have very small roof space, relative to the rest of your building size, it's actually not contributing, as much as, say, a bunch of semi-detached homes that has more space, and each one can have solar panels, but we know that's like less sustainable from a transport point of view. So you get into these really interesting like gray areas when you start talking about decarbonizing.
Absolutely. I mean, you can take it a step further as well. A lot of these systems work much better and much more efficiently if you have bigger ones. So you benefit from economies of scale. So it's great for households to have their own PV panels. Obviously, they benefit from it. But the efficiencies you would get if you had 5 houses that shared a small solar farm next to it with the same amount of PVs, or you could even go higher, it's way more efficient. But again, in high urban, density areas, it's where can you place a solar farm in the middle of a city, for example? So you end up with these solar panels on top of buildings instead. Like I said, still good, but it's very difficult for them to kind of make up for, especially if it's quite thin, high. It would be near impossible for it to make up for the whole energy demand for the building in that case.
It raises an interesting question about does the standard apply to, we'll say, could you apply it to a master plan of more than one building? Hi, Ross here. Just to let you know, I'm running a free webinar on the 25th of April about nature-led master planning and placemaking. I'm running this with Soham and Prachi, who are both designers and co-authors of the book Eco-Responsive Environments. We'll be getting in-depth into design strategies for delivering new places without sacrificing the environment. You can register for the webinar via the link at the bottom of the episode description. Hope to see you there.
That's a good question. I don't think that's the case at the moment. It does apply to a lot of different sets of buildings. So I think this has been one of the good things about, and I'll talk about this a bit more later, but it doesn't just cover office buildings, which is traditionally, it's always been office, resi, and maybe education or something. It goes to a lot of different buildings, industrial, different types of house dwellings, whether it's like commercial, residential, or kind of one house dwelling. But it's still primarily a building based kind of standard rather than master plan or group standard one.
Interesting. Maybe something for the future. Have a net zero carbon place standard as well. So those bigger developments. Can I ask around? And I'm showing that I haven't actually read much of the standard. I've only had a flick through. I only had a scroll through it before today's conversation. But also, it's probably useful for listeners who haven't read it either. Is it a whole life carbon standard? So, like, what are the bounds of what it's looking at?
So at the moment, it might not be completely accurate to call it whole life carbon. By the end of the year, it will be. When we think about carbon emitted in the life cycle of a building, or when we say the words whole life carbon, there's different stages to it. We have a modules kind of system where we split it into A, B, C, and D modules, essentially. The A module, which we call the upfront carbon, and that's at the moment what the embodied kind of targets are set for, is from the moment you take a material out of the ground as a resource, essentially. So you might dig some sand out or something to make some cement, or you might dig iron ore before you turn it into iron, turn it into steel. You transport it to a factory, you manufacture it into, let's say, steel columns. You take these steel columns to your project site and then you build them. That's called the A module. So it's up to the point where the building's been built, all of the materials up to that point. Then we have another module called the B module. Within that B module, you can find your operational carbon, which is due to electricity use. That has a target, but what doesn't have a target within that is over the life cycle of a building. Let's assume it's 60 years. You might need to change some of your furniture. You might need to repaint your walls. Your building services after 25 years, your air handling units, you might want to change them. All of that has carbon associated with it. You do have to measure it, but at the moment it doesn't have a target set for it yet. the plan is for the end of this year is that it will have a target once we have a bit more information around this topic. The other thing within that use or operation module that does have a target is refrigerants, and that's it's a very specific case of refrigerants used within building services. These refrigerants are agents that help with cooling and heating your building essentially. They have a leakage rate, so they might leak a bit during their use, and they have a global warming potential. Those have limits as well set to them that you have to meet. So that's the other thing. Once we move out of that kind of in-use or operation module, we start thinking about the end-of-life module. So building after 60 years, 100 years, however long it takes, the longer the better. It needs to be demolished. Materials need to be transported somewhere. There's site activities to demolish it. All those carbon emissions are included within that module. And then the D module, which is sometimes referred to as a circular economy module, is benefits or carbon benefits if you are reusing parts of this existing building for a future building, essentially. So you have to report on all of these things, but the targets haven't been set yet for them. The other thing where the targets are not considering at the moment is carbon sequestration. So we go back to timber, for example, and if timber absorbs carbon from the atmosphere, as we all know, or trees, not timber itself, but trees absorb carbon from the atmosphere. So they can technically have negative carbon emissions. If you think about how much they've absorbed versus how much carbon they cost to turn into tables, to turn into beams, to turn into a structure or anything like that, they might have a fairly low or negative carbon impact. But that we are reporting on that, but that doesn't get included within the targets at the moment.
Okay, that's a really interesting point. So can you explain a bit more around the rationale for not including the sequestration of natural materials?
Yeah, I think it goes back to the same thing we were talking about earlier, which is the main goal at the end of the day is to reduce as well material quantity, not just carbon. And it's a bit difficult with this, and it's a bit similar to the conversation around how your operational energy is going to cost less carbon, but you should still reduce how much electricity you're using. Just because the material might have good or low embodied carbon values should not lead to inefficient designs or overuse of materials when you don't need that. That's one side of it. I think the other side is our understanding of carbon sequestration depends a lot on understanding where the timber is coming from, whether it's there's also the question of if you cut down a tree, you turn it into whatever you want to do. Is the tree growing there in its place as well? Is it being replaced? How long does it take? What type of tree? It's a very complex topic, I think, at the moment. And there's still benefits. Timber should still be used. We do encourage timber quite a lot, but yeah, it's kind of having that full understanding. We're not quite there yet in knowing it.
Yeah, that's interesting. I mean, there's the principles, which is like makes sense that, you know, to use natural materials, and then it's actually getting down into the nitty-gritty of reporting on it and having accurate data and everything, and it sounds like that ggets very complicated very quickly.
It's not easy.
And what are your thoughts just generally? I'll move on a bit to talking about I want to ask you a bit about concrete and sort of the flip side of that, the very unnatural materials that have high embodied carbon. But I guess things like, I know there's more and more companies looking at things like natural fiber-based insulation panels, plasterboard, things like that as a sort of replacement for the more carbon-intensive or petroleum-based products. Presumably that's the same thing you'd say, you know, it might be sequestering carbon, but you just need to think about what's the emissions associated with its manufacturing and that kind of thing.
Yeah, I mean, concrete, we were talking about it as a team yesterday, that it's the second most used material after water, well, demanded material after water, which is
crazy.
An insane amount how much concrete's needed. And it is the most common building material. It's Yeah, it's great. If you look at it, it's a great material. It's durable. It allows you to build large spans. If once you've reinforced it with steel as well, it allows you to build whatever you want. Essentially, it's from that perspective, from building perspective, it's a great material. If left exposed, it has some other benefits in regulating temperatures inside buildings as well. It has high thermal mass, so it can retain heat for a long time and keep it on when the temperatures get low. It can also stay cool for longer periods of time. Yeah, in that sense, it's a great material. But the issues which you've mentioned as well, or the challenges, that cement has high embodied carbon, and cement's obviously the main constituent of concrete. But the industry and the supply chain within the UK manufacturers, everyone's looking at alternatives in a alarmingly fast rate at the moment, to the point where it's difficult to keep up with what's going on. And to give you an example, when manufacturing structural steel, when traditionally manufacturing structural steel, we were getting different types of waste material out of it, whether it's fly ash or GGBS. These waste kind of materials that are coming out of the manufacturing of steel.
For those of you who are not so good with acronyms, Salem mentions GGBS here, which stands for Ground Granulated Blast Furnace Slag. And it is a cement-like material whose main use is in concrete and is a byproduct of the blast furnaces used to make iron. So now you know.
GGBS and fly ash are basically materials that can be used to replace cement within the concrete mix, and as a percentage. So you might go and find concrete with 20% GGBS, for example, or concrete with 50% GGBS, and they lead to significantly lower embodied carbon because these materials are already being produced. This raw material is already being produced because you are manufacturing steel. So over the past few years, we've seen trends with GGBS. It started off with projects that I've worked on that had concrete with 0% GGBS, slowly moving towards a lot of structural engineers feeling more and more comfortable with specifying concrete with GGBS, and contractors being able to get it and working with it. There's some projects where some engineers were comfortable with around 50% up to 70% GGBS content in the substructure and up to 50% in the superstructure. It was very exciting for everyone using this because it was reducing embodied carbon massively. I think going up to 50% reduced your embodied carbon emissions almost by half for concrete. And as you can imagine, for a new building, structure is the biggest it's the biggest contributor to embodied carbon emissions, and it had not disadvantages, but it had two kind of things that we needed to be wary of. One of them is that the color was slightly different, which I've learned architects prefer the color with the recycled content. The other bigger challenge was program time. So concrete with higher recycled content takes longer to cure, which means that you might have to spend a few extra days, a week extra on site, and that means money essentially. So there was a few challenges. A lot of that was being mitigated slowly. So we've moved in a very interesting manner where we've hit this high point when it comes to this concrete. But I think it was a couple of years ago, where the conversations around this GGBS and fly ash, it's still a waste product coming from a very high embodied carbon manufacturing process. And also, everyone's asking for it. Are there going to be supply issues down the line with it? And at that point, there was a few different kind of conversations going around in the UK and in the sustainability world, which is, if you have a building that you're planning on building, is it better for you to maximize how much GGBS is in your concrete, or is it better to keep it lower and share that with every building being built in the UK? And it sounds great. It obviously, probably is better to share it across, but when you've got these targets, when you've got everyone wanting to hit better targets, everyone going towards net zero carbon, especially with the previous iteration, with the UK GBC iteration of net zero carbon, when you had to make offset payments at the end, you'd save yourself money if you went for the higher, essentially. So there was a lot of interesting conversations going around there. I don't have an answer to them personally, but it was something we were talking about as well. And since then, what we've seen, and I was working on a project very recently, which is very, very large industrial one with quite a big base, basically base substructure kind of concrete pad. We were looking at GGBS, and the structural engineers came back to us saying, right now, we're struggling to get anything towards 50%. The demand is it's just so much higher than the supply that we need to start looking at importing this waste material from other countries in Europe. And now where that's pushing us to keep looking even more at other types of cement replacement, whether they're manufactured specifically for this reason with lower carbon. And there's a lot of companies popping out here and there that are doing excellent work on this. But it is a very interesting conversation.
That is super interesting. Yeah, I had no idea that was sort of going on in the background. It's sort of like it's interesting to see how things shift and change, and the sort of systems at play and the unintended consequences sometimes of these decisions.
Yeah, absolutely.
Is there a goal or a sort of realistic goal at some point to have a concrete alternative that is zero carbon, from the get-go?
I think zero carbon, to go all the way down to zero, is quite a challenge, if you ask me. But yeah, the not all the way to zero, but we are seeing very low carbon alternatives. I think cost is still it's still an overarching challenge when it comes to some of these alternatives. But as with everything else, that will reduce with time, I think. When PVs first came out, I think the savings didn't justify their costs, but now it's a no-brainer to go for them. Their costs dropped so much over the past 20-25 years that it's just you need to go for it. It will save you money over a period of 20 years or 15 years or even less now. And I think that's what I imagine will happen. There's going to be demand for these cement replacement. There's going to be these net zero carbon standard targets to hit. If you want to call your building net zero carbon, everyone's going to be looking. People will potentially be willing to pay more for better alternatives. But like you said, there's so many little moving parts and fast moving parts. I think with concrete, we felt like this GGBS kind of and fly ash was really solving a lot of things at one point, but it was coming. And funnily enough, part of the reason why the supply of it is falling very fast in the UK, and this is a very interesting kind of interplay going on, is because steel manufacturing in the UK is changing towards a more sustainable way. So it used to be done through blast furnaces, where you could go up to around 20% recycled content with structural steel. That's changing to a different type of manufacturing process through electric arc furnaces, which was quite common at one point in Europe. So a couple of years ago, 3 years ago, we were importing some of this for some projects, that steel, because you can go up to, rather than 20% recycled, you can go up to 60% or even higher with how much recycled content the steel has, so better. But they're reopening a lot of these, they're opening a lot of these factories in the UK now that have these electric arc furnace capabilities. So you get higher recycled content in steel, but you're reducing how much waste GGBS is coming out, and as a result, concrete's being affected. It's a really interesting kind of mix of things going around, because steel, obviously, we talk a lot about concrete, but steel is another big thing. Steel has an even higher embodied carbon as a base, 0% kind of recycled content material. And that's where there's so many interesting kind of interplays going on. Yes, steel is higher, but you can hit like kind of less deep slabs with it, so you can have thinner plates, thinner floors with steel potentially, or kind of composite steel concrete structures. For end of life, when you think about the end of life of a building, you can really easily disassemble steel as well and potentially reuse it, while concrete, no, it's not that easy. You can't really take a concrete floor or a concrete wall and go and reuse it somewhere else, or a column. It's a lot more difficult to do that. So I guess you get to a question. We talk a lot about net zero carbon. We talk a lot about carbon. And then you have to ask yourself the question, is it just carbon? That's the question, or is there other parts to the story? And this is something we've been trying to do at Verte a lot, is not just purely think about carbon, but think also about which one of these materials uses more water, for example, because water is another important thing. And it might be lower carbon, but if it's using 10 times more water, is that actually a good thing? How does it affect soil eutrophication? How does it affect acidification of different elements? Does it release heavy metals that are toxic for the environment? Because none of these things sit within that carbon conversation often, but there are a lot of other things there. How many of these materials can be reused more easily? If you can reuse steel, does that justify the additional carbon cost to it, for example? So lots of, and it is moving fast. And on top of all of that, you have shifting costs, I think, as well. I remember I was working on a project, and it's an interesting thing. I was working on a project around the time when the Brexit vote was happening, and around that time, the costs were volatile a bit, especially with building materials that you were importing, because no one knew what was going to happen. And we were working on a project where the structure changed from concrete to steel and back from steel to concrete, purely because one of them became cheaper than the other overnight and then shifted back. And over a period of a month, I think it changed around 2 or 3 times. The structural engineers were getting asked to redesign both options because, and that is ultimately another reason why something's going to get picked. So there are so many moving parts going on there that are just, fascinating.
Totally. I'm so glad you brought that up, and I really appreciate you sharing that more holistic perspective on it, because you're right. I think we do, it's important that we really tackle this carbon issue and, help to decarbonize the sector, but it shouldn't be at the expense of other, polluting the environment, affecting biodiversity, using too much water, all this kind of stuff. It gets, I guess that's where a more holistic design process and maybe certification system is useful alongside the sort of, technical carbon stuff. I think of something like the Living Building Challenge as a really good framework that's not used too much in the UK, but I think is quite good.
Yeah, it's used, I think, is it common in Europe a bit, or?
I think it's mostly used in the US from what I could see on their website, but they definitely have projects around the world.
Yeah, it's interesting. We go back to this materials thing, and if you look at purely timber, for example, the embodied carbon of it, without sequestration, without anything, it does take quite a bit of carbon to create these, wood structures or timber structures. But ultimately, we both know it's much better to use than another material potentially. It's a regenerative material as well. You cut down a tree, it will grow back. But if you just think purely about carbon, it might not be the best. I remember we were doing a few kind of studies on CLT, which is cross-laminated timber for structural reasons. And with some of these, you do need a bit of steel as well support. So we were comparing that structure versus a concrete structure with very high GGBS. And the concrete came out so much better. And you look at it, and it is true. It is better in that sense, but you still need to think about that wider picture on what that actually means, and that it's a challenge because again, there's so many different things to look at, and it is challenging to get them all right. I think there was a Guardian article a few months ago about one of these carbon schemes, carbon offset schemes, where you pay money to grow trees. And I can't remember off the top of my head where it was exactly. I think it was somewhere in Brazil and South America where they were growing trees in a certain land, and they had to move a certain population of people from the land to be able to grow the trees there. So people were being forcibly moved away so that the trees grow. And then, you ask yourself a question, right? That has, I guess, a net benefit for carbon, but what about everything else? Where does that all fit in?
Totally. And I know it's, can be an element of like colonialism associated with, unintentionally associated with trying to do the right thing in terms of carbon, and where you think like we can just sort of, sort our problems out in the global south where land is cheaper and there's less regulation, and we can do these things like move people off land. It's just, it can't be we can do so much better than that. And, we need to morally make a decision to do better than that. But it takes art, it takes good journalism to bring these things to light, because they're not going to tell you that on their website when you go and buy the offset, So yeah, it needs to be reputable. Let's talk a bit about circular economy. So you mentioned this a few times, and I think sometimes people think about this, two separate things. There's like the decarbonization and the circular economy, and they're sort of two different bits. But I think what you're making clear is that they're actually very intertwined topics. So you can tell us a bit about that and how it fits in with an overall net zero approach.
Yeah, it is very intertwined. I think one of the main ideas, obviously with circular economy, the main idea is you don't follow a linear kind of method of thinking when it comes to materials. You don't get a material, use it, and it's with everything else. You don't buy something, use it, and then throw it away. But instead, let's say you start with buying something, you use it, and then you repurpose it for another reason, or you find another way for it to use it without it going to waste or going to a landfill, for example. And I think with buildings, there's so many different ways we can talk about. The traditional way of thinking about it with buildings as well is when you are building something, reduce the waste as much as possible on site. During the operation, recycling, having a good way for reusing materials there, for example, whether it's waste paper, whatever it is. But I think sometimes you can extrapolate that to the whole building as well, and thinking about a whole building, that can you repurpose existing buildings? Can you reuse them? The big thing in the UK over the past, it's now been years, was the M&S building in Oxford Street, whether it should get demolished because it's not fit for purpose and something new built in its place, or whether we can do some work on it and refurbish it. And there were so many different varying viewpoints on this. The government was involved. But it raises a very important question, is if you have a building that's around 20 or 30 years old, do you need to demolish it? There's a wide variety of justifications that come, one of them being that it has asbestos, a lot of asbestos, for example. Another is that it doesn't have very good accessibility, for example. So it might not have an elevator, some of these older buildings, or that they just want to build something much bigger because that will lead to more houses or more office space, for example. So there's a lot of good reasons to why you might want to demolish. But even with all of that, I think we need to become better at reusing, or trying to maximize what we can do, whether it's refurbishing, or even if you do demolish a building, how much of it can you reuse on site? If it has steel, can you do something with that steel? Right now, I guess the default or the business as usual is when you demolish something, a lot of the materials do get recycled off-site and then maybe used elsewhere. But we want to push even more, rather than just recycle off-site, use it somewhere else. Let's keep it inside. We're working with quite a few clients who are very keen around this topic. So some of them have quite a few buildings around the same area, and they're refurbishing a lot of them. Raised access floors, they might take them out from one place because they don't want them anymore, and instead of buying new raised access floors for another one of their buildings, they just shift them into the other one, which is incredible. That's the best use of this. We're I guess within the industry, we're scared that things are not being utilized up to their full potential as well. Another big topic is office spaces. When they're leased in the UK, you might have someone renting an office or leasing an office for a period of 3 years. They fit it out. They want to put their colors there. They want to put everything that belongs to them there. After 3 years, they leave. Whoever the new occupant comes, they might want to do things differently. So rather than certain fit out items lasting for 6-7 years or however long they should last, they instead last half the time. And that just leads to a lot of unnecessary carbon buildup that could be avoided. So one way we're trying to do it is it's become very hard to justify demolition in the UK as well. A lot of councils are pushing back big time on this. unless you show that you've gone through a process where you've explored every single option, where it really is the only option. And in addition to that, if you do decide to build something new, then you need to start asking yourself some difficult questions. How long is this building going to last? What am I planning on doing with it when it reaches its end of? And you need to plan ahead. You need to say that, yes, it has 50 tons of steel. That steel can be disassembled. It has this that can be used, even if it's 60 years away. The other interesting thing is thinking a lot about longevity as well. So it shouldn't just last for 60 years. It should really last for longer. And thinking on one of the more, I think, interesting and fun topics to think about, is quite a creative exercise. It's flexibility and adaptability of your buildings. So if you are building an office space somewhere, 5 stories, and the use is offices mainly, you need to think about whether in 20 years or in 30 years, if it gets sold to someone else, or if someone else buys this building, or if for a reason the use of the building needs to be changed. Can this office become a school? Can this office become a house? Can it become a different type of office? It's open plan at the moment. Can it become not open plan? Can it have individual office, or it's individual offices? Can you make it open plan? And you need to think about some very interesting questions. So we've looked at things like demountable internal partitions, for example. So you can make spaces bigger or smaller because if someone else comes and says, actually this doesn't work, I need it all to be open plan, and they just knock down all of the internal partitions, it's much easier to be able to take them off and reuse them somewhere else, for example. We're thinking in terms of structures, for example. Can this hold higher weights potentially in the future, even with building services? If you've got something, a ventilation system that's servicing one big room, if I split this room in half one day, if I decide to put a partition in between, would it still work? Can both sides still get air? Or am I shutting windows off completely off one by partitioning it? Am I still getting daylight into both? A lot of interesting questions around that. So it plays a major role in carbon, because eventually, if you do all of these things right, then you reduce the risk of having to do big works again. That's what we're trying to avoid. We want to build buildings that last a very long time, even if their use changes. And what we see in the industry, there are a lot of projects that involve buildings that are not that old, and it's unfortunate. They have to be done sometimes, but we need to avoid this happening in the future. And it's not easy, but yeah, that I think is a very big part of the carbon story as well.
That's great. Yeah, I often think about what we did right historically that we've sort of forgotten the lessons of, and I often think of the typical terrace British houses, Georgian, 200 or 300 years old, and over that time they've been huge, really adaptable into different uses. So they might have started as one large house, and then over time it's been subdivided into flats. And then at some point, someone knocked together 3 of them and made a hotel. And then, and then there's a shop on the ground floor, or, it's all this adaptations over time. But we don't necessarily build like that anymore. A lot of our housing is very house and cannot be, anything else. Maybe you can build an extension on, but you can't really do anything else with it. So yeah, it's interesting going back to those more traditional forms that had a more adaptability built within them. I guess it's challenging for clients though, who are hiring an architect to do something very bespoke for them. They maybe don't necessarily, they need some convincing, I guess, to go down and, build in some adaptability.
It is challenging with the bespoke projects, and you also need to have a conversation with the client, telling him, what if you go broke in 20 years and you sell your building to someone else and they want to do something different with it? Obviously difficult to have that conversation, but even them, they might want to see a change in use. I think what we've been seeing is a lot of buildings from the 70s and the 80s just seem to be, they're just getting not just knocked down, but a lot of them are going away and being replaced with something else. But having said that, we are seeing a lot of our clients and a lot of developers in the UK who have the right idea with this. So I work a lot on refurbishments and fit outs, and it's just amazing to see that. A lot of the projects might have been old industrial buildings that are being turned into co-working offices now, for example. Lots of very interesting things where you're keeping the beautiful outside facade. You might be changing your windows, for example, but it retains its original state. It retains the structure, and just purely by doing that, when it comes to embodied carbon, you're reducing your cost a lot as a person, because you're just doing the refurbishments, but also the embodied carbon emissions fall by almost half. One way the UK Net Zero Carbon Standard is trying to encourage this is the targets set for refurbishments, in my personal opinion, are easier to achieve than new build ones. And as they start dropping year on year, the way I'm seeing it is very few buildings will be able to hit the new construction kind of targets for net zero carbon, while the ones that are refurbishment, they're still going to be fairly a bit challenging, but way less challenging compared to a new build. And I think this signals the idea that we need to think less new building and more kind of more refurbishment. I guess the other challenge with it just sounds less exciting sometimes. Everyone wants a fancy new office. I can think of a few examples of things I've seen as I work, of people wanting that. And the refurbishment just doesn't sound as exciting. It doesn't signal a big kind of,
Yeah, for your big corporate headquarters, you don't necessarily want to. Yeah, I get it. But maybe it's a question of mindsets, isn't it? And maybe as sustainability becomes a more important part of doing business in various industries, that might be a flex for companies to do and say, oh, we got this building from the 70s and we turned it into this like amazing headquarters. And
I mean, to be fair, we're already seeing a lot of this. The private sector push has been incredible in the UK, and I've done a bit of work in Europe, but my experience in Europe is a lot less. But what I see in as a comparison between the two is, in Europe, a lot of the sustainability initiatives tend to be led, kind of government-led or regulatory-led, for example. So you've got a lot of new regulations coming up, a lot of new requirements. In the UK, it's been incredible to see how much of it has been led by the private sector, by sustainability consultants. It's been amazing. There's so many initiatives, whether it's LETI, whether it's the UK GBC, whether it's the new net zero carbon standard. It's been very much consultants, people putting their own time into this, and their companies offering them the time to do this as well, to do the research, to come up with new things, and the developer side as well. A lot of companies that are building buildings or they own buildings, they're looking for good things. I mean, we get challenged from some of our clients on how we can help them. They want to do better. They've got money set aside to do better. They've got the will to do better, and it's been a very nice journey seeing that as well, because I think if you ask any sustainability consultant how did it feel maybe 10, 15 years ago, you were the last to be called into a meeting, sometimes forgotten. It wasn't on the forefront. Well, now it's become a much bigger deal. A lot of people want to hear about it. It's become an exciting thing as well, and I think it's exciting times in that sense.
That's great. That's really great to hear. I think that leads me on to an important question that I had, which was, what are the current barriers or the challenges in the UK? I know we've talked about some, getting net zero from a sort of niche topic that a few really good, projects are doing towards it just becoming a mainstream thing, which is obviously where we need to get to, for all new buildings. What do you see as being sort of the roadblocks towards doing that?
Yeah, there's a few different things. I think supply chain, there's always trouble there as well on what materials we actually have. I think that's been improving quite a bit. But what's been in particular challenging in the UK is the lack of what I see is the lack of environmental product declarations compared to other countries. Sorry, and that goes back again to saying the EU is kind of more regulatory led, because a lot of their countries, and I think the EU as a whole now, has specified that all manufacturers need to have environmental product declarations for their projects. So I think where it becomes a bit of a struggle is if I'm working for, if I'm doing a building in France, for example, and some kind of concrete was specified, or some kind of finish or paint was specified, it's a lot simpler for me to find the actual real carbon emissions for that, because it would have an environmental product declaration. In the UK, there is a lot of very good companies or manufacturers who do have them, but we're still lacking quite a bit there, I think. That's been a very big challenge, because it means the lacking information is a big challenge in general, because you're unsure whether to go for something, a worst case scenario, just in case, a default material, a generic material to replace it. I think EPDs needs a big push, and I think it needs a big push regulatory wise in the UK, that manufacturers need to start having environmental product declarations. I think that's a very important thing. The other thing within the UK, I think the net zero carbon standards, obviously for the whole country, but I think things happen in London a lot more than in other places, and I think there's still projects that we get outside of London. There's still good work being done outside. We've had a couple of very interesting headquarters done that wanted to go for the net zero carbon standard, the UK GBC iteration of it, but one was in Glasgow and one was in Edinburgh as well. So there's still exciting things happening outside of London, but it still feels like a lot more is going on in London. I think the other thing is in general, I guess, educating some of the teams that we work with, not educating, but kind of having that become still even more the new norm. If you work on a big project with big architects, big engineers, big structural engineers, that kind of stuff, everyone will know what you're talking about. It will go smoothly. But recently, a lot of councils are asking for embodied carbon assessments and whole life carbon assessments to be done and compared against the target set by the UK net zero carbon standard for single dwellings as well. So even if you want to build a house, you still need to go through quite a complex process. And I think there's a bit of a challenge there, because first, it adds cost. Doing an assessment adds cost. Understanding everything adds cost. Having everyone sit together, going through workshops adds costs. But also, people are not yet used to it. I think it's getting everyone used to it. It also feels like there's maybe in terms of professionals, we need a higher supply of people who can do this, because there is a lot of demand for it. There's a lot of work going on, but I think that is a challenge that the UK is well equipped to deal with. The UK's got a very interesting kind of position when it comes to sustainability. A lot of the work that's been going in education around sustainability has been going on for a lot of years. Ross, I think CAT, where you went, has been ongoing for 50 years, maybe 40 years?
Yeah, since the 70s.
Since the 70s. The environmental design and engineering course I did at UCL started in the early 70s as well, I think mid 70s too. So we've got quite a nice cohort of directors, of senior people, of junior, of lots of different things. And I think when compared to some of the other places around the world that are now starting to take sustainability more seriously, we're in a good position. So I think that kind of supply of more sustainability consultants, and more understanding, it's a challenge now, but I'm very optimistic about it.
That's great. Yeah, I mean, that makes total sense to me, that like there's a really important place for the deep topic experts like yourself, the consultants, but also just everyone needs to upskill to just actually know how to do these things, even if you're not doing all the detailed work. So
I mean, yeah. I always say that my job is done when I'm not needed anymore, in some sense. Yeah. That would be the ideal place. If everyone does sustainability, everyone understands, then you wouldn't need us anymore. And yeah, I would be happy with that.
You might be ready to retire at that point.
Yeah, maybe.
Amazing. We're sort of getting to the end of our hour here, so just thank you so much. And I don't want to take up too much of your time. Maybe just a final question, and hopefully this isn't this isn't too long a question to ask for the final one. But I had someone who listens to the podcast write in response to my newsletter with a question about the standard. So thanks, Ray, for sending that in. But the question is, could the principles of the UK Net Zero Carbon Building Standard be effectively adapted for other regions, or are they too dependent on the UK's climate infrastructure policies, etc.?
That's a very good question. I think at the moment it's the net zero carbon standard is set for the UK, purely for the UK. Obviously, there's aspirations for it to be applied globally. The methodology behind it can be followed, I think, wherever, and it follows methodology set by the by RICS, which is the Royal Institute of Chartered Surveyors. The idea behind undertaking an embodied carbon assessment and studying your operational carbon at design stage rather than just measuring it at the end, the idea behind looking for good alternatives, looking for locally sourced materials, all of that stuff, that can be applied anywhere in the world. I think where the difficulty is that you can't, I suppose you can't verify your building with a net zero carbon standard if it's not in the UK. So in that sense, it can't be applied. You can still follow the principles, you can do whatever you want with it, but it won't be verified kind of technically as a technicality. And the other thing is the way that the standard was created. The targets set by the net zero carbon standard are based on the UK's kind of carbon budget as well. So they're calculated as a top-down approach to be able for the UK to be able to meet the kind of the Paris climate target. So they might be less applicable. And I know, for example, in countries like France, where I think 70 to 80% of their electricity grid is purely nuclear, it's a very different conversation around how much things emit carbon, how much electricity you can use, how it works. So yeah, but it's an amazing document that was done by so many people within the industry who gave up so much of their time to do it. There was a massive effort from everyone. So it's definitely worth considering when looking at an embodied carbon assessment or kind of thinking about net zero outside of the UK as well.
That's great. Thanks for that. And I'll just say, for anyone who's based in the US or interested in this stuff applying in the US, I had a conversation with Katrin Klingenberg, who's the head of the Passive Building Institute in the US called FIAS. And they've been working on passive design standards and net zero carbon principles standards adapted for the USA's different climate zones. So whether that's sort of arid desert or like temperate East Coast or, wherever you are, there'll be different principles depending on your climate. So that's a useful one for people to go and look to. And she also said that other countries have now been looking at that and taking it and adapting it where they're in a similar climate zone. So there definitely has to be knowledge sharing around the world, but also like, don't just think that because this is an amazing document for the UK, it's going to be perfect for, a totally different country. Have to adapt it to the context. Amazing. Just as a final thing, let people know where they can learn more about the standard and where they can get in touch with you or your colleagues.
Absolutely. The standard's got its own website. So it's the UK Net Zero Carbon Building Standard. I think you just have to sign up. You can download it. Right now, we're just waiting on a few pilot projects to be able to study it. It's got its own LinkedIn group and a mailing list. So definitely keep up for updates with it. And anyone who wants to kind of give their time to potentially help with it as well, there's always opportunities for that. It's obviously voluntary based, but it's a great opportunity to talk to a lot of people and get to know more about the standard. I think, Ross, if you can drop my email as well, and if anyone wants to reach out to me, by all means, I'm more than happy to answer questions. And I've mentioned Verte a few times where I work. If you've got any more questions around this topic, we'll be more than happy to help you with answering them.
Amazing. I'll have links to everything in the episode description so people can go and click on those. Thank you so much, Salem. Really appreciate it. I still have more questions, but we'll have you back on another time.